there's one thing which the creation work does, it displays the physical beauty that God has put into his creation. And that's one thing which I was very encouraged to see Stuart Burgess in his book, Hallmarks of Design, emphasizing, and I would encourage you to read his book. He, of course, is going to speak on that subject, and I'm looking forward to it very much indeed. I'm stressing one aspect of design, which is flight. And just before I go on there, I've got an interesting little cartoon which displays a scientist who is trying to decide whether intelligence was needed in the beginning. And if this slide were really true, then it would mean that no intelligence was needed, and it might have something more to say about the scientist rather than God. But I'll leave you to think that one through. But I like to stress the biblical side first when it comes to this matter of design, and indeed the whole aspect of creation. May I stress that in my personal view, and I think it's the opinion of many here, that we need to be led by the Scriptures. We need to have our thinking governed entirely by that book. We need to grasp firmly what the Scriptures say first before we come to anything to do with science. We should unashamedly be Bible-first creationists. I'm looking forward to John Pete's talk when he, I know, will be stressing the doctrines which are affected by creation. I believe in every aspect of our ministry, creation, flood, and many of the other things which follow on to do with creation, the implications to behavior today, homosexuality, and all the other things which obviously flow from a base which is not Bible-based. All these things are going back to the Scriptures. That's why I wrote that book, Genesis for Today, because it's my firm conviction. And you'll see that in the slide here, I put in the beginning, God created the heavens and the earth, and you notice that the word used is bara. Most of us know that, and it means creation ex nihilo, out of nothing. Not in existence before, there was no pre-existent material, and Hebrews 11 verse 3 brings this out very well when it says, so that things which are seen were not made of things which do appear. Secondly, we need to stress that creation was by the spoken word of God. And that's marvelous, because it means all that God did in Genesis 1, we say all, tremendous power, when he said, and God said, for instance, in verse 3, there was light. God said it, and there was. So there is power in the word of God. And in another verse, which is not on the slide, it says in Hebrews chapter 1, verse 3, upholding all things by the word of his power. So not only in the creation, but also upheld now by his word. Psalm 148, verse 5 says, he commanded, and they were created. I was very blessed by listening to the tapes by John MacArthur. If you've not yet heard them, do hear them. They are brilliant, and he expounds these points much more ably than I. I've just given you a slight overview, in fact, of one of his tapes. I think it's the second tape in. Let's now come to our subject, the intricacies of flight. But it's important to remember those things I've been saying. We therefore expect to see things made which show the power of God. And indeed we do. When we come to looking at things like the Saturn rocket going up there some while ago, it was only made by design and attention to detail, with a specific purpose in mind, and with great precision. We all would accept that. I hope one day to go and visit the Kennedy Air Base, which one of my church members went to recently, and he may be very envious. I must go and see it myself. But I believe that when you look at that, you'll see the Saturn rocket, which is absolutely huge, which they sent up on the first trips to the moon. And then you'll also see the space shuttle, where again, more recently, it showed the importance of design, attention to detail, purpose, and precision. Now, we're considering flight. That's one example of flight, of course. The space shuttle was quite remarkable because it came back into the air, having been in space, where, of course, the wings were no use, so they had to pay attention to the tiling in order to make sure that it didn't heat up coming into re-entry, at least not heat up too much, such you lost the wings. There was a lot of careful design went into that. Well, coming to aircraft, a bit more prosaic compared with the space shuttle, but again, you need attention to design, to detail, to purpose, and to precision. And of course that was also true for the rather ill-fated Concorde, which up to recently had such a spectacular safety record. Now, of course, we all know that engine number 2 and engine number 1 failed drastically on takeoff due to a detail of design. It's been shown, not with all the ramifications yet worked out, but it does seem to be due to a burst tyre on takeoff. So again, this illustrates, sadly, negatively, that design, detail, purpose and precision are necessary in order to get aircraft to work, man-made aircraft. Well, why can't we use the same logic when we come to Arctic terns, seen here on flight from the North Pole to the South Pole? And then they make the journey back again when it comes warmer in the North Pole. They then make the journey all the way back again, 12,000 miles from the South Pole to the North Pole. The only reason some of them don't make it is because of birds of prey on the way. Remarkable, isn't it, that we apply the logic to aircraft, but we don't apply the same logic to much more versatile birds. In the days of creation, we notice that day 1, of course, is light. Day 2 is waters above, waters beneath, and so it goes on until we come to day 5, when we read that the fish and the birds were made, highlighted here, because day 6, animals, insects, and man. Day 7, rest, but please notice, day 5 before day 6, that birds were made before land creatures. And it's an important point. Just like we have light made before the sun, which befuddles the astronomer, we have something here which befuddles the engineer, or those who believe in evolution that reptiles changed into birds. Land creatures were made after birds. And I find that an important point. Do you see the importance of sticking to Scripture first? Don't try and meddle with the Bible. Keep the Bible as your standpoint, always. And let the Bible govern your science, because it shows to us immediately that we cannot have birds coming from land creatures. Now, when we come to other examples of flight like this, pelican complete with tip veins at the edge. You'll see I'm going to talk about that in a few minutes, a bit later on, but we find remarkable intricacies in flight. Before I do that, though, let me just show you a Lockheed TriStar, which is seen here, flaps down, coming into land at Montreal in the snow. And you'll see the flaps coming down mechanically, and as I came down to land in the snow there, I could see the screw being driven out in order to drive the flaps down. Very, very prosaic compared with the next example of flight. Here is Swan Mark 1, flaps down, nose forward, coming into land at Swan Lake. Not Tchaikovsky's. And you'll see here that the flaps are increasing the camber of the wing. And of course, there's no mechanical screw. It does it without any apparent effort compared with the Lockheed TriStar. Again, design, detail, purpose, and precision in this engineering marvel that surely God made. There has always been in man the urge to fly, like this poor man jumping from what appears to be the Tower of Pisa and presumably met his end. But then the gentleman on the right achieved it by not using wings. He chose to go up in a hot air balloon. But there's always been this urge to fly in men. And of course, finally, with man-powered flight using wings, not hot air balloons, the Wright brothers in 1903 at Kitty Hawk in North Carolina, although when I'm in New Zealand I have to be willing to be stood corrected, because apparently there is a claim that flight was first achieved in New Zealand, so you do just have to watch it there. But generally it's accepted that in North Carolina was the first at least world recorded event of flying man-powered. And of course a lot of effort went into that, as we all know. They didn't achieve that with ease. A nice little aside here is that the Wright brothers, when the King of Spain came to visit their aircraft, said, sadly, we don't fly on Sundays. You can't visit us then, but we will show it you during the rest of the week. Full marks for standing on the Lord's Day for those Wright brothers. Whether they really knew the Lord, I'm not sure, but full marks to them for that. Now, we have French members here, and it's nice to have Gilles Berthold, but Gilles will be proud to know that, of course, it was Blériot who first crossed the Channel in July the 25th, 1909, from Calais to Dover. One up to you, Gilles, there. Of course, Gilles was reminding me yesterday that the English, he thinks anyway, seem to celebrate their defeats by naming train stations after those defeats, such as Waterloo and King's Cross. I did actually tell him the truth, because I thought maybe others could do that. But of course, that's man-powered flight. Now, why should there be any difference when we come to flying creatures such as this black kite flying over Hong Kong, or the hovering kestrel next to it? We've often seen kestrels, as we've probably driven on the motorway here. You'll see kestrels very often just hovering, with their marvellous ability to move their wings in such a way as to hover. We see two black kites under a Boeing 737 in the next slide, which emphasizes to me something really obvious to us here as creationists, but it's sadly not so obvious to the evolutionary world outside, that we say that the aircraft above is designed, and yet these creatures, which are far more versatile, seem to are regarded as those not designed at all, which I find just totally incorrect as a scientist. Now, there are three main types of creatures which have the ability to fly. There's birds, there's flies, bees and wasps, butterflies and moths, and then there's, of course, the bats, which are mammals. And in the past, there was a fourth type, probably now extinct. I say now extinct, but there have been some interesting reports of possible sightings in New Guinea of what might, in fact, be pterodactyls, but we've got no confirmation of that. Now, those last ones, the bats, may possibly have been connected, the pterosaurs may have been related to bats. We don't know for sure, but we know that there seems to be some similarities between the pterodactyls and the bats today. But we'll regard the pterodactyls as extinct, and we'll say that there are three creatures which fly. Let's look first of all at birds, and let's look at some of the intricacies of birds. Birds, of course, in case you didn't know, have hollow bones. Now, the hollow bones are essential. That's how we get the lightweight engineering for bones, for birds, which is essential, of course, for them to be able to fly. We have, on the contrary, we have solid bones, which means that when we're falling and etc., we're not likely to break our bones. The bird's bone structure then is exceedingly light. It's hollow, unlike land-based creatures, and it's made of struts similar to aircraft wings. Indeed, the structure shown to you at the top is the Warren's truss arrangement, which was copied from birds and used to great advantage in giving strength to wings whilst keeping them light. And of course, the fuel is often put into the aircraft wings as well. So it's really quite absurd, I will use that word guardedly, but it was used quite a lot yesterday, and I do agree with its usage. It seems to me scientifically absurd for the National Geographic in July 1998 to claim that you've got a dinosaur in your backyard when you look at a common crow. Because a dinosaur, from all we've seen from the fossil record by geologists, it didn't have hollow bones. Certainly not the land-based dinosaurs which they claim birds have come from. Now, that sort of point was never dealt with by David Attenborough in his program some while ago, The Life of Birds. It doesn't seem that really attention is ever given to detail when it comes to examining this whole matter of evolution versus creation. It seems to be an awful lot of glossing over the important points. The phrase, of course, that the world has is that the devil is in the detail. May I say, and I don't wish to be irreverent here, that as I said at the beginning with the scriptures, it is in fact the Lord who is in the detail. Now, I say that reverently. I don't mean to be irreverent. But you see what I'm saying? That actually the whole matter is really decided upon by the detail. And one's got to have the detail right. The other thing about birds, of course, is that they breathe entirely differently. The respiratory arrangement of a bird is not like our lungs, which I show on the left. but is, as you will find in Michael Denton's book, which is a lovely slide here, of the bronchial tubes and the parabronchial tubes connected to the main tubes, which operate in an entirely different way, such that the air going through the lungs of a bird is always one way, and it's a two-cycle event. So the bird, when he or she breathes in, right, it fills one sac, but not them all. In the meantime, some sacs are beginning to fill up with carbon dioxide, and it breathes in again, and in the same movement as breathing in extra oxygen, some of the carbon dioxide further downstream is actually pushed out. So there is a continual movement just in one direction, and the bird does not have to exhale against the oncoming stream. Now, the intricacies of flight are furthermore shown when we look at the bone muscle of birds. First of all, let me show you an overall diagram of the bird, which shows all the feathers. And you'll see that I will return to this in terms of the bone muscle later. That I will refer to the humerus here and the muscle which controls that humerus. But let's just move on to feathers just for a while. You can see here the secondary feathers and the primary feathers. That in itself is a remarkable matter. If you're going to talk about reptilian changes from scales into feathers, you've got to also talk about how on earth did you get secondary feathers changing into primary feathers, if one's going to go that way, and how are you going to cope with the fact that tail feathers have to be very, very different to those primaries and secondaries, and that you need to develop this tail, which is essential for bird stability. Not all birds will operate in the same way with their tails, but most birds will need a tail. Butterflies, of course, don't operate in a different way, as we shall see, but all birds will have tails. You see, there are all sorts of details here which the evolutionist doesn't explain. Now let's come on to feathers themselves. I always like to say that you can knock evolution down with a feather. Here we have a pigeon feather, and at the base and the tip, we are going in that direction and following the same direction here, with an illustration of the barbs coming off from the main stem. And you've got here the barbs, which of course you can see, but when you look under the microscope, you can see barbules. And the barbules going northwards on this picture have hooks on, and the barbules going west to east on this picture have ridges on. And that means that the hooks attach to the ridges. So what you have is something rather like Velcro, except instead of having hooks for the bottom part of the Velcro, as it were, you have, instead of hooks, you have ridges, so that the hooks cling onto the ridges and they can slide over the barbules, which in this diagram are the horizontal west to east ones. And so you get this movement of sliding. And so it's a marvel of lightweight engineering. It is preposterous to propose that that came about by accident, because you would need different information to make the barbule coming on the right than the barbule on the left. If you had left-handed barbules both sides, it's a bit like what we were thinking about proteins yesterday with David Roseveare, that the Stanley Miller experiment could only produce left and right. In that case, you needed left only, if you remember what he was saying yesterday. Well, in this case, you need 50% left of one side only entirely left, and right-handed ones entirely on the right. You can't cope with left and right on both sides. It would just be nonsense. You need left-handed on the one side and right-handed on the others. It's a similar principle. And, of course, the information comes from the DNA, which stores all the computer programming necessary to make sure that this all happens correctly. And if we look at the blow-up of the keratin feathers, we will see, of course, that although it's true that both are made of keratin, that is, scales from reptiles and the feathers, to say that the two are connected is preposterous, because the information to make scales, although it's the same material, is not the information to make feathers. It's the structure. It's the detail which shows us what is in fact going on. You can't gloss over the detail. And of course, if you've got a sliding joint, you need to have preening. And how does a bird preen? Well, it preens, the next slide, will show you by the bird turning its head 180 degrees, as you'll see in this white pelican, and getting its oil from the base of its spine. The preening gland is at the base of the spine. So when you watch your budgerigar in the mornings preening its feathers, do notice that it can turn its head 180 degrees. Don't you try and do it, because you'll break your neck doing it, particularly if you're getting over 50. But, even if you do lots of press-ups, you still won't be able to turn your head 180 degrees. You see, all these things have got to be right for the bird to survive. It's got to be able to get at its preening gland in order to put the oil on those feathers, because the sliding joints must be oiled properly such that you don't actually lose the feathers, which will become frayed. If you just keep on moving a sliding joint without oil, then the feathers will just disintegrate. And that's indeed what happens when you pick up a feather, which is now disconnected from the bird. Eventually, if you start moving it around a lot, you'll find that you can't get it back to its pristine condition. The reason being, you need oil on that sliding joint, and you haven't got the oil. At least don't try and find it on your body, because it will be the wrong oil. And the oil that a bird needs is specially made just for that purpose. Now, let's just move on a bit and summarize first what we've said. The wings are made of feathers. The bones must be light. They can, of course, be made of skin and scales. We're coming to that. The breathing must be special. And the feathers, of course, must be correctly oiled. There must be a preening gland. There must be the ability for the head to turn 180 degrees. But also the wings must be aerodynamically shaped. We can't forget that. It's not any old wing which will do. The manoeuvrability of fixed-wing aircraft, such as the red arrows flying across the screen, is nothing compared to the manoeuvrability of birds, such as this eagle coming down to catch its prey, or the owl in the top of the picture, or the albatross, which is flying, coming into land somewhere in the Antarctic, I would think. Now, I want you to see that here we've got wing tips, and those wing tips are very important for an owl, because the owl has a trailing vortex, just like any bird has a trailing vortex. Whenever you get lift, you get something which comes as a result, which is called induced drag. You never get something for nothing. That's the law of thermodynamics. Second law of thermodynamics. You always get a loss of useless energy. But you can recover some of that, what might have been useless energy, by actually putting tip vanes. Now, you may have seen certain Boeing craft and Lockheed craft in the last 10 years putting tip vanes on their liners. And they've saved a bit of fuel doing so. But who did it first? I tell you, God did. With the owls, with the eagles, which are also showing a tendency to doing it there. But particularly this eagle, do notice it. That tip vane is most important. The tip is actually slightly raised, and it's actually breaking into the trailing vortex and using some of the energy so that the trailing vortex is not quite as great as it would have been without the tip vane, which means that it's got more energy going into its flights. It also means that the turbulence is reduced behind the wing, such that the noise is not as great, such that the poor little rodent doesn't hear the advance of the bird, poor little creature. But we'll leave that matter, but the aerodynamics is most important. Just one other aspect of aerodynamics, and that is the leading edge of a bird. Some birds have leading edge feathers which allow some of the air to enter, which keeps the boundary layer attached. If you lose your boundary layer, then you've had it, because you lose your lift. Because the whole principle of lift is that the air actually goes a further distance over the top of the wing and than the bottom, and therefore you get reduced pressure on the bottom, top rather, and you get lift as a result. Now, if you're in a very high maneuver situation, you can sometimes lose the attachment of the boundary layer next to the wing. And if you lose the attachment of the boundary layer, you've got problems. The only plane which operates with an unattached boundary layer is, do you know? There's one plane, which I showed earlier, which uses an unattached boundary layer. And Concorde. Concorde uses vortices going over the wing, and it's a totally different principle. But here, most aircraft and most subsonic aircraft and most birds use this principle, which is the conventional principle. Now, to keep that boundary layer attached, some of the feathers deliberately allow air in, and effectively there is a suction effect which keeps the boundary layer attached. We move on now to the muscles, which I said that I'd mention, which we need to just look at briefly here, this section, which is blown up here. On the next slide, we'll come into it in more detail. You'll see here that here is the humerus, which is the main bone supporting the wing, the first bone. Here it is on that original slide there. And this is the scapula, which goes into the main body of the bird. And you've actually got a rope and pulley arrangement here, where effectively this muscle will contract and the other one will lengthen, then the other muscle will contract and the first one will lengthen. And you get this arrangement between two muscles pulling or pushing, as the case may be in the cycle of the wing movement. Now, those muscles are very important, and you must have this keel here within the body of the bird in order to actually make those muscles operate properly. All the bone structure has to be there in place, as well as the muscles, to operate a wing. It seems to me preposterous to say that all these things, such as the bones, the breathing arrangement, the feathers, the muscle operation, the bone structure to go with those muscles, the fact that the bones are hollow, all these things have to be right for flight in birds. And so we see this lovely fan-tailed pigeon getting aloft using those principles. And we move on to a bird which is most extraordinary, because this bird, unlike the fan-tailed pigeon, which can only go one way, the hummingbird can actually go in many directions. It can fly sideways, it can fly backwards, it can go up and down, it can go wherever it will. It would seem almost like an insect if you actually visit the hot gardens which usually have hummingbirds in this country. You can see the hummingbirds for yourself. It's rather lovely to see them in the wild in America and other places. But the hummingbird has the ability to move its wing in a figure of 8. And the muscles are further refined, such that it is able to bring a power stroke not only on the downward movement of the wing, but also on the upward movement of the wing. And that is the key to how a hummingbird can fly in any direction it will. This is the broad-tailed hummingbird hovering alongside a honeysuckle flower. And then I thought I'd blow up the next one because it's so beautiful. It really does show the hummingbird actually putting in its beak into the trumpet of a flower. And you can see on the detail of the slide, if you come close up, you can't see it, probably most of you can actually see the tongue coming out into the bird, into the flower. And of course it feeds on nectar, and it has a double groove in the tongue in order to pour the nectar in. The tongue actually comes out roughly 10 times per second. That movement itself is absolutely amazing, apart from being able to hover at the same time. If it didn't have the ability to hover, but it had the beak, the long beak, it would be no use, because it would come into the flower and it would go straight through the other side. It wouldn't get any food. And of course, the opposite would also cause a problem, because if it had the ability to hover without that long beak and the tongue necessary to get its food, it would be trying to get its food to no avail. And yet people say that these birds came about through creatures changing into birds. The Archaeopteryx was claimed for a long while as a halfway house, but if you look at the Archaeopteryx, it has curved feathers. Even if it isn't a fake, and I believe it's probably not a fake, despite what Fred Hoyle says, I think it probably is actually genuine. I think it's just an extinct creature, an extinct bird, and indeed birds have been found in lower strata. In fact, the curved wings are just the same as I showed earlier for the owl, where I pointed out that these tip veins here, these curved wings, act as winglets for reducing the drag and the noise. In the Archaeopteryx, they are just curved feathers, which may have been used for that purpose in strong flight, or else they were there just simply as normal curved flight feathers. Let's, though, just consider one other bird which exists today, which is like the Archaeopteryx in one respect, because the Archaeopteryx, they claim, was something changing from a land creature to a bird because it had claws on its wings. They failed to realize that the Hoatzin, while it's a juvenile at least, has also claws on its wings, and the ostrich as well. So there are birds which do have claws. And so when people talk about the Sinosauropteryx of China or the Confuciansornis bird, which has also been found in China, I would say to you that they are either birds, as the Confuciansornis I think probably is, and it's probably an extinct bird. The first one, we don't need to go back to it, that was the Sinosauropteryx. To my mind, looked more like a reptile, and it's very interesting that in the same shales as these recent China finds were made, there are fish which are fossilized as well. Now, we may have varying views as to the catastrophe which may have caused this. I perhaps would tend towards the flood. But whatever was the cause, it's very interesting that fish were found in the very same strata, and they don't emphasize that. So there was a disaster that took place, which took away these creatures, some of which I think are extinct. The mutations which they claim have changed reptiles into birds are really no use, because all they do is actually remove information. They don't add information. Here's this cormorant, which is a flightless cormorant. And those wings are actually degenerating. They are not getting better. That cormorant no longer has need, perhaps particularly to fly a great distance, and for various reasons. We don't deny natural selection within bounds will actually, in this case, allow that bird to survive. But it won't change it into something else. It's still a cormorant, a rather mutated version of a cormorant. So when National Geographic in July 1998 claimed that there is a whole progression of finds between reptiles and birds, they really were basing things on a very shaky foundation, apart from the fact that one of the fossils they found was actually a conglomerate of two fossils stuck together, but we won't go into that. That might embarrass them. But even taking them at face value, the July 1998 National Geographic magazine showed this progression. You can't read the writing here, but if we just summarize the chronology that they claimed, you actually got 120 million years in their dating. I don't agree with it at all. 80 million years, 90 million years going backwards, going back again 120 million years, 120, 150, and then jumping to 115 and to today. So even on their own basis, their chronology was wrong in detail. So people looking at the detail, if they really did look at the detail, would actually surely come to the conclusion that they weren't getting their facts right. Let's move on to butterflies. Most extraordinary in their beginning, as we all know, they started off as caterpillars, then they move out of the chrysalis, and then finally, once they come out of the chrysalis, they hang their wings up to dry, rather like on a washing line, and you'll find that within a few minutes of strong sunlight on those wings, they are ready to fly. And the scales of a butterfly defy some sort of evolutionary change to explain them. You will find that in the fossil record, butterflies are exactly the same as butterflies today. Absolutely no change. The delicate membranes of this lace-wing moth on its path taking off illustrate, to my mind, the exquisiteness of God's creation. And this next slide shows two butterflies and a moth peeling their wings, producing extra lift. And this is what's called the clap and fling principle, discovered by Weiss Fogg about 20, 30 years ago. Weiss Fogg was a researcher who collaborated to a certain extent with Sir James Lighthill. We move through the next slide, which shows a woodland greyland butterfly, showing the clap and fling principle. And then we come to the next slide, which showed some earlier cinematography pictures, or pictures drawn from a cine film, where you can't see the numbers here, but it's going through the cycle of an insect using the clap and fling principle. And the clap and fling principle is basically this, that if you examine an insect, slow down the cine film or video footage now, And you see what happens. They bash their wings at the top, and then, as you notice, that grayling butterfly, it gradually peels its wings away. And so there is a rush of air to come in and fill the gap made. If you just have 2 sheets of paper and you pull them apart quickly, right, you'll notice that there is a vortex as the air comes in and fills the gap. And the butterfly uses that principle. And other insects do as well. And it's called the clap and fling principle. It means that there is an extra lift provided due to the vortex movement of the air. But we'll move on now to the next slide, which actually illustrates another principle, which is a little harder to understand. But this is a principle called the tunnel effect. And you'll see here, now you have to remember that this is the upstroke of a butterfly. I've talked about the downstroke. Now I'm talking about the upstroke of a butterfly. And this comes from the book Insects in Flight by Brackenbury. And if you want to look up the book, it's a very, very interesting book to read. And it really shows that the research has advanced quite considerably. Now we're looking from underneath here, right? So we're actually looking from the ground level or thereabouts, because it's not necessarily horizontal, the butterfly, but it's actually moving its wings upwards. And by actually moving the leading edge into a pronation position, which means nose down, supination means nose up, but into a nose down position, then actually as it's moving its wings like that, it actually causes air to be drawn in such that is another vortex which is actually moving under the wing, right? And there is a tendency then to move the creature further upwards as a result. You can see that there is a nose-down position of the leading edge, and it's moving its wings on the upstroke. And this is called the tunnel effect, because with the back wing, also back hind part of the wing, actually curving in, it actually funnels air in and increases its lift. This is a separate to the clap and fling principle, but it shows another marvelous use of aerodynamics. I think the master of insect flight is the dragonfly, or its companion, the damselfly. Both of them start off underwater. Quite extraordinary. Well, that's a thing in itself. How on earth can we develop a creature which starts off underwater and when it's an adult cannot go back into the water? Water is foreign to it. It's a bit like, of course, the caterpillar and the butterfly. It's the same principle. You've really got a complete change in, and the metamorphosis really in the creature. You've got this dramatic quantum change in its lifestyle. Now, when you look at a dragonfly and its 4 wings, there is yet another effect that this creature can do. In fact, it's said that Sikorsky, looking at this very principle, developed helicopters as a result of it. Because this is yet another principle that can be used. Because he's got 4 wings, he can use them rather like a propeller. And he can actually cause there to be a throughput of air through the wings rather like a propeller. Now, of course, he can't turn the wing all the way round, but it's remarkable just how versatile these wings are. And he's able actually to encourage a throughput of air through the very disc which these wings actually circumvent. So we call this really the sort of the rotor effect. That's yet a third effect that can be used by these flying insects. Please note that dragonflies are exactly the same in the fossil record, except larger. You can get them apparently up to 3 feet, which I wouldn't have liked to have met. I think it would have been rather a nasty experience. Nevertheless, we do see them 6 inches long today. It does raise questions about how these creatures were able to fly when they're, of course, when you increase the size, you don't necessarily increase your surface area. In fact, you don't, because surface area goes up like distance squared, and the size goes up like distance cubed. So how are you going to support the extra weight? And it does raise questions about how these large flying creatures, indeed the large pterodactyls, how did they fly? How did they ever get off the ground? And of course, the answer may well be that before the flood, the air pressure was a lot greater. We don't know how much greater, but I suggest to you that that may be the key, scientifically. That if the air pressure was greater, then you don't need a lot greater. You perhaps only need perhaps 50% greater. Can't go too great, otherwise you'll endanger lots of other things which depend on air pressure to do with the human body. It is known, actually, that with increased pressure and certainly an increased oxygen content of the atmosphere, 21%, I teach my students for combustion, and they all know that it's 21%, 79% nitrogen. Well, if it had been, say, something like 30%, you can't go to 50%, you'll have the whole Earth going up in flames. But you could increase the oxygen content, and that it may have been the balance which also changed the pressure. So there's a number of things there which are worth researching into. And it would be interesting to have further research lines made along these ways. If there was any way of proving what the air pressure was in the early Earth before the flood, it would be, I think, pay dividends to try and see whether that really was the case. Here it is. This shows the movement of the wing. Now, this is a complicated slide, but let me just summarize it. Where you twist the wing, in comparison with where you've got two movements. You've got the movement of the wing up and down, right? And you've got the twisting of the wing. Now, where you twist the wing in relation to the movement up and down is something that has been looked at by Charles Ellington at the University of Cambridge, and has also been looked at by other authors which are mentioned here, Dickinson et al., and this was produced in Science, 1999. Charlie Ellington has done work experimentally, and these guys as well, where they have actually put wings in a whole box full of liquid. I don't think it's water, it's another liquid that they use. And they actually examine the movement of insect wings by making a model. And they then have movements such that they can twist these wings. And they have found that if you twist the wings in a symmetrical pattern, you get one answer for the overall lift. This is the overall lift that you get from the one complete cycle. If you actually twist the wings just after you've got to the top of the upstroke and you're making the downstroke, so it's a delayed option, then the lift goes down. But if you, on the other hand, just twist the wings just before you're getting up to the top. So you're getting up to the top and you twist the wings and you're still going up a bit and then come down, right? You actually get more lift in the complete cycle. And it's found that damselflies and dragonflies do just that. They increase their lift by using this other aerodynamic principle. So there are 4 extra aerodynamic principles that I've gone into in some detail there. So I think it's quite remarkable that these things are found in nature, and indeed, as Stuart Burgess brings out in his book, we ought to be actually looking at these principles and seeing whether we can use them to great advantage. We'll move to the next slide, which briefly shows bats. Bats, of course, come in all sorts of varieties. The Microchiroptera are the ones which usually have radar, as is seen with the greater horseshoe bat homing in on a moth here. Not all bats have radar. The next slide shows flying foxes or fruit bats. These do not echolocate because they have good eyesight. But bats, of course, have wings made of a completely different structure. The bats have wings made out of skin over a hand made of lightweight bones. And people have claimed, of course, that they came from shrews and that they gradually changed through little stages into bats. And so people have drawn diagrams like this, carefully showing the various stages. They don't tell you, of course, that the only things which are found in the fossil record are that one and that one. And if you look at the next slide, bats are exactly the same, even in their scale 50 million years ago, which of course we don't accept, as they are today. There are absolutely no evidence of change. So to summarize, we have birds, we have flying insects, we have bats, all with their various subheadings there, bones and feathers for birds and many other things which have to be right. Butterflies, moths, flies, bees, beetles, even all those are different types of flying insects. Bats, with their wings made of skin and radar, some of them. If evolution were true, then flight is supposed to have evolved 3 times independently, because no evolutionist makes any connection between those 3 types of flying creatures. To say once would be fantastic. To say twice is ridiculous. To say 3 times is preposterous, scientifically. Migration is another thing which can't be explained by evolutionists with ease. Birds, butterflies, fish, and turtles all migrate. Bird migration, well, why do birds fly south in winter? Well, somebody has once said that it's because it's too far to walk. But here's the Arctic tern again, which migrates, as I said, 12,000 miles and back each year, 24,000-mile round trip. The Pacific golden plover migrates from northern Canada and Alaska to a little island called Hawaii, which we all know, a distance of 2,000 miles, and the adult goes first and leaves the young to make their own way without the adult's help. And yet it gets to that island with no problem. We believe that it's to do with the magnetic field which it's picking up by magnetite in its brain. We're not entirely sure even now whether that's the answer, but it's rather looking like it's picking up the magnetic field. Somehow it has a map of the whole world. With aircraft like this cockpit shown in the next slide, of course we've got to use sophisticated equipment. Even butterflies migrate, and it's been found that they have magnetite in their bodies as well, very tiny little bit. And migration of butterflies, of course, means large distances. It means a correct payload of fuel, and it means often no training for the young, as is illustrated best by the well-known monarch butterfly, which feeds on milkweed, and it goes through 3 or 4 generations, can be up to 4. Usually it's about 2 or 3 generations, going from South America or Central America, some of them going across the Bay of Mexico, and some of them going up the west coast of California. And you'll see that the monarch butterfly has remarkable ability to migrate. What is amazing is that there are 2 or 3 generations involved. So once, grandmother starts making the journey, she doesn't make it, but she passes on the information to her son or daughter to carry on making the journey northwards. And even he doesn't make it, and then he carries on the information to grandson or granddaughter. A brief word about bees. I found this lovely. Bees are well known for their waggle dance, which was only discovered in the last 30 or 40 years. The worker bee comes in. I hope to get a video clip of this. I'm sorry I didn't make it. But there was a lovely video clip, and I couldn't grab it, which actually shows the bee actually making this waggle dance. And it's the number of motions in the waggle dance which tells the other workers how far the food source is. And then it actually will do it in a certain direction. And if it's in a particular direction, north is upwards, and if it's to the right, then it's east. If it's to the left, it's west. And so it communicates, as we well know in the hive. This is a fairly general bit of information. But also, the bee, in the next slide, is shown here, of course, feeding on nectar. But how does it fly anyway, particularly the bumblebee? The next slide. You see, as you can hear the flight of the bumblebee nicely going on with this, which I did ask for. The bumblebee has recently been examined by a little-known gentleman called Mr. Rex Boys, and credit to him. He's an amateur scientist, and I think he's put his finger on something here. You see, the bee buzzes, in case you didn't know, and when the bee buzzes, people have said, well, why does it buzz? Because surely the motion of those wings, which is about 50 to 100 hertz, could not make such a big noise. And it's been shown that really could not be the wings. Now, it's not yet been proven what does cause the noise, but Mr. Rex Boys has suggested, and there is some evidence to support this theory, which has not yet been proven, that it's actually to do with the spiracles on the side of the bee, which is to do with the way the bee breathes, right? The bee breathes not in the way we breathe. It breathes through spiracles on the side. And in the motion of the wing coming down, it's reckoned that the spiracle is actually ejecting some air out of its abdomen and its thorax, just at the point when the wing is coming down. Well, if you blow on a surface which is coming down, it increases the lift. it also will cause an acoustic signal. And it's reckoned, but not yet proven, that the spiracles are the cause of the noise. Now here's another little bit of information, which if we can grab that bit of information and use it, we might be able to improve flying vehicles in the future. Notice it's always that way. We learn from God's creation, and it's not something which possibly could have come about by chance. The information, of course, is stored on DNA, which we heard a very brilliant lecture on yesterday, and I couldn't for a moment copy David's expertise. Suffice to say that I do work a little bit in information theory, and I do recognize the importance of computers. I'm sometimes a slave to these machines, not understanding all the programs that go into making them, but I do understand the principle, and I think most of us do, that information is on this CD. The plastic doesn't make the information. I believe we ought to stress this argument. I wrote an email to Professor Richard Dawkins when he was reader at the time at Oxford University, and I had an email exchange with him. And I did suggest to him that we needed a language first in order to make any headway to construct the DNA. And in order to get that DNA to work, you need to have an agreement between the inner part of the cell and the outer part of the cell, where the information is being taken from the blueprint factory in the middle to make whatever cell, whether it be the eye, the ear, the wing that we've been considering, the feather. There's got to be that information there stored. And the information has got to be written in a language which we must all agree upon, whether it be English, whether it be French. Well, it could be French, gee, but I think I'd struggle. But, whether it be German, whether it be whatever language, whether it be DNA language, we have to agree on the language. And I had the email back which said, yes, I do grant you that. Well, in granting that, I would maintain that Professor Richard Dawkins was actually admitting the most important point to us. He was actually showing us that he had no answer to the basic origin of information. And that is the crucial point. The information must be there to begin with. If we look at the next slide, we'll come to the Rosetta Stone. And it was Champollion, I was told the name yesterday, Champollion, who discovered the Rosetta Stone. Another Frenchman, gee, one up to you. And the Rosetta Stone was, of course, the key to the advance of understanding Egyptology. Because it was only due to recognizing that this was the same message written in 3 languages, hieroglyphic, Greek, and, forgotten the last one, Demotic. It's only because it was written in 3 languages that they were able to then understand what the hieroglyphics meant. But the same information was there, and that's the important point. And this illustrates the fact that information is not defined by the squiggles. The information could be written in any language, but the information is the important thing. In this case, it was the same. So if we go to the next slide, we've got these lovers going down the sand saying, John loves Mary. Now, if a Chinese man comes along and says, what do these squiggles mean? He'll have no understanding as to the emotions that were going on between these two, as they expressed their love to each other and said, John, the world, I want to know John loves Mary. You see, it's only when a person who understands the language comes down the sand and says, well, how embarrassing. Here are these 2 English people who say that John loves Mary. Even the briefest message, if meaningful, speaks of an intelligent source. That's the point. We come to our last slide with that lovely verse of John 1, which says, in the beginning God was the Word, and the Word was with God, and the Word was God. All things were made by him, and without him was not anything made that was made. In the beginning was the Word. I said at the beginning, the power of God's Word, where he spoke into existence living creatures. Part of that speaking into existence was writing a language on every living cell of every living creature. May God be praised.